Today we're going to look at Unit 4, Lesson 5, and we're going to explore the concept of something called conditionals. Imagine you wanted to make a decision about what to wear to an event. Name two pieces of information that you would want to know. How would you use those to make your decision? You also have a copy of the digital manipulatives document to open if you'd like to follow along and try some of these exercises. You'll be able to do so with those manipulatives. Recall that with these sticky notes, we were representing two kinds of information: numbers, the digits 0 through 9 on yellow sticky notes, not in quotes, they would actually be numbers, and strings, which are text, characters, inside double quotes on red stickies. There is another kind of information that can be stored in computer programs, and that is something called a Boolean value. A Boolean is a value that is either true or false. Now we're going to put these on blue sticky notes. So if you're following along on your digital manipulatives, you would write true on one and false on the other. Those are the only two Boolean values. Here's an example of an expression that evaluates to a Boolean. 3 is less than 8. Evaluates to true, because 3 is less than 8. The less than sign is a comparison operator. It's a clue that we need to stop and evaluate for a Boolean value. The comparison operators are less than, greater than, less than or equal to, and greater than or equal to. When you're looking at an expression using comparison operators, each side of the expression must be reduced to one sticky note before you can apply the comparison. In this example, you would first evaluate 3 plus 6 and replace it with 9. Then you can evaluate whether it's 9 less than 8. So it's a question. 9 is less than 8? False. Try these expressions. Evaluate them and decide what the Boolean value is of each expression. The first one, you would replace 6 minus 3 with 5, and 4 plus 1, 6 minus 3 is 3, 4 plus 1 is 5, so replacing those each with one value, now you're looking at 3 is less than 5. That's true. The next one, 12 divided by 6 is 2, 3 minus 0 is 3, 2 is greater than 3, false. In the next problem, 7 minus 3 gets evaluated first, that's 4. Then multiplied by 3, that's 12. So this whole side gets replaced with 12. Is 12 less than or equal to 10? False. The last question uses two equal signs. This is the comparison operator to determine if two things are equal to each other. The single equal sign in computer programming represents assignment. This double equal sign is how you compare two numerical values. So in this example, 9 plus 5 is 14. 10 plus 4 is also 14. Is 14 equal to 14? True. Any of the values in an expression could be a variable. In this case, we have an expression where on the left-hand side, we have variable lives plus 4. And on the right-hand side, we're comparing that to the variable score minus 1. So to evaluate this expression, we first replace each variable with its value. And this is what the computer would do also. And then we combine so that each side has only one value. And then we compare. 9 is less than 9. False. 9 is not less than 9. 9 is equal to 9. Any expression that can be evaluated for true or false is known as a Boolean expression. So this whole thing is a Boolean expression. All right, let's talk about that decision process that we started off the lesson with. Let's say you have a decision to make. Can I go to the movies? I'm allowed to if it's before 8 o'clock. So when you want to make a decision, you need to think about what information do I need to know? It says create a baggy variable to store that information. Give it a name. Maybe you called it time. Can I go to the movies? I'm allowed to if it's before 8 o'clock. Here's a little flow chart to show the process of making a decision. Creating a flow chart helps us think like a computer. At the top, we're listing variables that are needed. Your variable might be called time or clock or really anything. It doesn't matter as long as you use the same name every time you refer to that variable. So I am calling this variable time. Let's step through the flowchart with an example to see how it works. Say it's 9 o'clock. Can I go to the movies? First, I assign 9 to the variable time. Then I move on to the diamond section. This is the decision. I have to compare, is time less than 8? So I need to stop and evaluate that Boolean expression. First, reduce both sides to a single value. In this case, we need to replace time with its value. So time is 9. Now we need to basically read that Boolean expression and decide, is it true or false? 9 is less than 8. That is false. So we're going to follow the path of the false and say, I cannot go to the movies. Here's another decision that needs to be made. Have I won the game? I'm not sure if I've won the game I'm playing. I've won the game if my score times my lives is greater than 10. I guess that's the rules of this game. So what information do I need to know? We will make a variable for that. Think about it. You kind of need two variables. You need score and lives. Let's look at an example. The first test case, score is 3 and lives is 3. Whoops. Score times lives, in that case, is 9. So we would replace score times lives with 9. 9 is greater than 10. Turns out to be false, so I haven't won the game yet. The second test case, score is 1, lives is 10. We're going to stop here, and I'll let you evaluate the next two test cases. Test case 2 is also false because 1 times 10 is not greater than 10. It's only equal to 10. So still false. And test case 3, when you multiply score times lives, you get negative 10, which is also not greater than 10. So it's false. And you haven't won the game. I haven't won the game. All right, challenge. Is my dog older than me if his age is converted to human years? 7 dog years equals 1 human year. What information do I need to know? Create a variable. What would this Boolean expression look like? Maybe you have two variables, dog age and my age. The expression dog age times 7 is greater than my age sums up the comparison of the challenge. So, let's say that my dog is 2 years old and my age is, let's say, 38, which it's not. But we'll just use that as an example. So my dog, 2 times 7 is 14. That is certainly not greater than 38. Perhaps you have a chance at your dog being older than you when converted to human years, but I don't. So I am coming out, this expression is false. I am older than my dog, and I will be for quite a while. All right, what if my decision requires several steps? What if the condition is I can adopt a cat if I have $40 and I am over 14 years old? Can I adopt a cat? I can if I have $40 and I'm over 14 years old. What information do we need to know now? We need to know how much money we have and what our age is. Now, this is a kind of two-step process. We need to evaluate, is our age greater than 14? And then, if it is, we need to evaluate, do we have enough money? Do we have $40? If it's true, we can adopt the cat. If either of these things is false, we cannot adopt the cat. That's what the word and implies. Both of these conditions have to be true for me to be able to adopt the cat. So let's try it out. If I was 17 years old and I had $39, I would pass this first portion because my age is greater than 14. So we would follow the true path. But then I evaluate money equal to 40, and that turns out false. So I cannot adopt the cat. Boolean values are a type of information, so they can also be evaluated in a Boolean expression using operators, but in this case, it's going to be logical operators, not arithmetic operators. The logical operators are, there are 3 of them, and, or, and not. The and is represented by 2 ampersands, or is represented by 2 pipes, and not is represented by an exclamation point. If something is, if you have a compound condition and only one of them, the parts, is true, then the entire expression evaluates to false for the and logical operator. For and, they both have to be true, like our example of the cat, adoption. So we're going to take a look at truth tables in the next few slides. We're going to change the color of the sticky notes a little bit. The Boolean values will still be on blue stickies, but the true will be a dark blue and false will be a light blue. Here is a truth table for the and comparison operator. If you have an expression with a true statement on the left side and a true statement on the right side, the result is true. Both things have to be true for an and comparison to work out true. If either one of them is false, the result is false. And of course, if both sides are false, then the entire expression is also false. What do you think the or table is going to evaluate to? If one of the values is true or the other one is true, how do you think the entire expression would turn out? True. With the word or, if the first part is true or the second part is false, if you have an or with one true and the other false, the result is still true because this one's true. They don't both have to be true. Or means it can be either this one or that one that's true. They don't both have to be true for the entire expression to evaluate to true. So if the first is false and the second is true, the final result is true. If they are both false, that is when the or evaluates to false. Either may be true for the Boolean expression to be evaluated as true when or is the comparison between them. The not table is easy. The results are just opposite of the Boolean value that you put there. Not true equals false. Not false equals true. Not just reverses the logic. Now we're going to use logical operators to combine several Boolean expressions into one expression. We call this a compound Boolean expression. Can I adopt a cat? I can if I have $40 and I'm over 14 years old. So let's try it out. Here's the expression. Money equals 40 and age is greater than 14. If I'm 15 years old and I have $40, this is how it would work. We would replace money with 40. We would replace age with 15. On the left side, money is equal to 40 is true. On the right side, 15 is greater than 14 is also true. When you have the and expression, you need both of them to be true for the entire thing to be true, and we have that. So this evaluates to true ultimately, and we can adopt the cat. Okay, now it's your turn to make a flow chart. On a scrap sheet of paper, think back to the warm-up where we discussed making a decision on what to wear to an event. Write down the variables at the box in the boxes at the top. Inside the diamond shape, create the Boolean expression that will be used to make the decision. Draw true-false lines to the possible decisions. And, extra challenge, try using logical operators and, or not in your Boolean expression, and add branches to it with multiple decisions. Okay. All right, some key takeaways from this lesson. A Boolean value is a data type that is either true or false. Comparison operators, like less than, greater than, equal to, not equal to, less than or equal to, greater than or equal to, those indicate that you are looking at a Boolean expression. Each side of a Boolean expression is reduced to a single value, and then the single values are compared and they always result in a Boolean value, true or false. Boolean expressions can also include logical operators like and, or, and not. Both sides of the logical operator are reduced to a single Boolean value. A truth table is used to evaluate the reduced Boolean expression to a single Boolean value. A decision is made with the single Boolean value. A flowchart can be used to illustrate the steps of making a decision with a Boolean expression. All right, we are now going to watch this video together and move on to lesson 6.